Record to the cloud.
Cool. All right. Welcome, Dev Alliance, to our February meetup. We're going to get started here. We have our host online, Aaron Johnson, who is going to talk to us a little bit about Sigstore and how we as developers can utilize this technology to increase our security. So without further ado, thank you for joining us. And Aaron, take it away.
All right. So how does it look? See it okay?
Yeah.
All right, great. So to the wide audience, no, I'm just kidding. Hey, Ty and Sean, thanks for joining. So Project Sigstore. So I'm going to start with the tagline that the Project Sigstore has been kind of feeding this. They want to be the Let's Encrypt for code signing. They want to make it as easy as Let's Encrypt made getting TLS certificates. And they're pretty darn close, if in my estimation. I think they'll pull it off. A huge community behind them, trying to get all this stuff. Now, the thing about Project Sigstore is they didn't really invent a whole, like all these different products. You know, a lot of the people that are involved with it were the original authors, but they've added features to it and they've brought them together. So there's like 3 or 4 moving parts, and they're all open source and they're all free. And they're kind of combining some really cool workflows to get these code signing certificates over to folks for free. But more to the point, they're also allowing you to make this stuff extensible. So you could plug it into your environment. It doesn't have to be on their hosted servers. And without further ado, I'll talk a little bit about myself. So, okay, so that's me, old picture. Yep, so I work with Alaska USA Federal Credit Union, and previously our team is called was on the certificate services product team. We've done a little bit of reorganization, but I'm doing a lot of that work still. And then before that, I was a consultant for a couple of places, built PKIs for like power plants, internet service providers, Native Corps, Alaska Native Corps, healthcare providers, some other little smattering stuff. And in between gigs, I tried to make $1 zillion by engineering a way to get custom keys or unique keys onto physical access control system cards that also store logical access, so smart card, PIV stuff on the same card. And that was very cool and interesting, but didn't make much money. But it allowed me to get pretty into NFC, near field communication. And so I went ahead and tried my hat at inventing. So invented a little game. It's like a treasure hunt game concept, and that has a patent pending. But yeah, you just sort of scan these tags with your cards and move you around a course. So look for that in the future, hopefully. But enough about me. Let's talk about why we're here. Project Sigstore. So very cool stuff. Like I said, they're trying to be Let's Encrypt for the code signing space. And if you think about it, you know, a while back before Let's Encrypt and that whole movement started, there was, you know, it was not the majority of web traffic that was encrypted. But today, 80–90% easy is encrypted web traffic. And in fact, some browsers just won't let you even look at unencrypted web traffic, because Let's Encrypt made it free and made it easy. All you have to do is throw the little agent on and prove your identity, and you get a renewing cert for free for your website. So that's sort of their push and why they're doing this, and how they're hoping to increase adoption for code signing, and specifically code signing in container images. So in the Project Sigstore space, there's 465 plus active contributors. So in the community, there's a whole bunch of people working on this stuff. And more impressive are the partners they have. So ChainGuard is a for-profit arm of a lot of the people that wrote this technology. But look who else is working with them. You have Cisco and Google and Hewlett-Packard and the Linux Foundation, et cetera, et cetera. Really cool stuff with that collaboration. People are plugging this technology into their build systems and into their, their web hooks if you use them, or, they're just Kubernetes is integrating it. It's getting rapid adoption because there's a big need. And so the last piece on the slide, like I said, this is just an introduction. Okay, so to back up a little bit, my background is in virtual machines and servers. It's pretty legacy stuff, I guess, if you want to call it that. But I had no idea what containers is, container images. And so to actually get my hands around this technologies, this code signing stuff with Project Sigstore, I had to learn all that. So it took at least 2 months of learning containers, Docker files, how they work, what's immutable about it, what gets left behind, what are you actually signing, where are these signatures? It was a lot of work. And so I say that because I am not an expert. I'm very green at this stuff. And you'll be able to see that in some of these demos. But the idea behind this project is not entirely new. But like I said, the way they're stringing this together and the way they're making this easy to use is very cool as well. So you can get a full implementation of a lot of these pieces in containers. If you're using Macs, this is all ready to go with Homebrew or Brew. You can use Go to go and grab this thing. I don't believe it's quite in a repo yet. You can go ahead and grab compile it yourself on GitHub. It's out there and it's free. So without further ado, let's look at what's behind the scenes. So these are the moving components, right? You've got FullCo, and that's when we're talking PKI, you need a root of trust. So that's the free root CA. Right now it's a single tier, and it's been around for a while, and there are plans to get an intermediate in, but they just had their first key signing ceremony a couple of months ago, and there was about 5 people there, several members from that community of vendors and groups and universities I showed at the beginning, and it was pretty exciting. I didn't see it, but because I got stuff to do, but it's available to watch. And that's an important piece because that's starting to establish a reputation and a trust. So with that first key signing, FullCo was open for business. They're ready to issue out certs, and they are. I'll show you how you can get one. And then the other piece to this is Recore. So the whole idea behind this is to make this transparent in a sense. And so the way they do that is every cert you get from FullCo's free root certificate authority gets appended on their transparency log. And that Recore, there's also tools that you can run a whole Recore instance in-house. You don't have to use the cloud. But you can go ahead and use the RESTful API and just go ahead and monitor this transparency log. So if somebody's signing with your name, you can find that out very easily. If somebody's trying to get into your repository, that's going to show up. That's the idea. And certificate transparency logs are certainly nothing new, but the neat thing about them is they are append only, so you can never really delete anything. So it's going to be a very large log, but it's all out there. And Cosign, that's the engine that's doing the signing, and we'll see that. And it's got this really cool feature called keyless signing, and that's you never write a key to disk. It's all just stored in memory. And then OpenID Connect, that's that protocol that's allowing you to prove whom you say you are. And it is what allows you to authenticate to that root CA and get your certificate. The neat thing about FullCo is the certificates only live for 10 to 20 minutes. They're very short-lived. So your certificate that you're signing it with is going to probably expire before you're done with your session, but they also do the timestamping service. So that's how the code will live past the life of that signature. So the cert that does the timestamping lives a lot longer than 10 to 20 minutes. But you also stamp your email address on the code. And this will work for service accounts too with Google as well. So you can integrate this into your pipeline as well. And having that identity source is really important for this because you want to know who is writing your code. So when you think about it, when you do a Docker pull, you don't really know what you're getting. There's a lot of inherent trust. And this idea of signing everything provides a bit of a trail that you can audit and piece together who wrote that package. That's the point of signatures, right? They not only lock code in time, because once you change that code, it's going to invalidate the signature, but they also attach an identity to it. And that's where OpenID Connect plugs in, gives you that identity. They have 3 identity providers right now. They're working with Azure AD and Microsoft's system of doing OAuth 2. They're working with GitHub and Google. So I imagine they're going to expand that, but it's very slick, and we'll watch the keyless mode in action. And so it talks a little bit about Fosu. These are all stock images. Okay, I don't know where that is, but the idea of that image is to provide that root CA, that sense of the root of trust that exists at the base of every PKI. And the root CA that we get our free code signing certs, like I said, these certificates only live for 20 minutes, and you can't get a cert without using OpenID Connect to prove your identity from your identity provider. So they're not actually trying to create a new way to authenticate, in the sense that you don't have an account with Project Sigstore, but leveraging your identity provider that has all these pieces baked in with multi-factor, with smart cards, or you name it. The 3 players that they're leveraging are very robust controls already baked in. So why not leverage them? And that's where OpenID Connect comes in. And then Fosu, of course, is the target for getting the actual certificate. The next piece we talked a little bit is Recore. And Recore, we'll see the CLI in work, but it does have a RESTful API-based server, so you can validate and monitor. You can also run it on its own in your own environment, so you can run your own transparency log in-house. And that's really nice, because when you think about where we're going with supply chains, oh man, I'm gonna mess this up. You know what I'm saying, supply side security. We just got through that big Log4j. Well, the biggest puzzle to that, and the thing that came out of it, is people don't really know what they're getting. So the idea of having a software bill of materials is going to leverage some of this stuff to get a chain, a whole kind of log, if you will, of where the software is coming. And signatures play an integral part. You lock that code in a point in time, stamp it with your identity, and then you can even affix a tag to it. So when you go to inspect the signature, you could even tag it with a dev, you could tag it with prod, whatever makes sense for your environment, your workflow. You could, and then your domain will get on there. So the idea is working towards this automated bill of materials. So when you're in the enterprise space, you do your initial audit when you buy a product, but it's very rare that you'll audit all the code that comes down with updates and with upgrades. There's a lot of trust. So we're kind of moving out of that environment as a world. We do need a paper trail for all this stuff that we're coming down. Open source is a fantastic concept, but without that trust, it's tough. And so these tools, especially Recore with that log, are going to help and provide some authenticity and some chain that you can go ahead and validate. Cosign, very cool. This stuff is awesome. So this is the signing engine. It will go out. You can sign from the registry, and all Open Container Initiative registries will work with Cosign. You can generate keys in 30 different ways. It's very powerful. You can bring your own PKI, so you can plug this Cosign engine right into your already established public key infrastructure. You can store keys in hardware. You can use a key management server to find the keys. And it also has support for YubiKeys and PIV tokens, and of course PKCS11. So if you want to just leverage the protocol, and the libraries are available again via open source, that's an option too. And then the nice thing is, we talked about that, is it stamps every time you get a cert from FullCo or your own root. You can stamp that certificate on that transparency log, and so then you can go back and query it, and you see the timestamp as well, and it locks that code in that point of time and affix an identity to it. So very cool, very powerful stuff. And this was the piece that I think is sort of their flagship. That's kind of what I learned from researching this. They're really proud of this, because this whole idea of a keyless signing, you'll see me flip it on in the demo. It's quote unquote experimental, but the code is ready. They just have to put that experimental tag on there because of legal reasons. You know, this is a new thing, keyless signing. So, you know, we're a litigious country. So before we can turn off the experimental mode for keyless signing, the lawyers have to read it. But that's what you'll see with the demo. But I wanted to talk about that because that's how OpenID connects to this whole thing. And that really is going to allow workflows to just use this stuff invisibly. And then of course, OpenID Connect. So that again is a protocol to affix an identity to a signature and provide that authentication piece. So you use OpenID Connect, go ahead and prove your identity and receive a certificate in keyless mode. And the keys that you generate get stored in memory. They never get written to disk, and the cert then will sign the certificate request that you issue via Cosign with this FullCo root CA, and then stamp the email address that comes through via OpenID Connect as well. So let's talk about keyless a little bit. So these are the 4 pieces working together for keyless signing. Just if you use Project Sigstore just out of the box, so for their hosted entities and their hosted Recore transparency log. So Cosign signs, FullCo gets the cert, Recore logs that signature, and OpenID Connect proves your identity or provides the identity for the root CA to issue on your behalf or to you. So this is not necessarily a new idea. Spiffy, Spire, there's tools that have been doing similar things, but this is just sort of making it available as well as beefing it up. Really cool stuff. So I'll show how this works. Now, again, I'm pretty green in this space, and that's not the point, but I did want to, me and Andre were talking, you know, it's small. If you're watching this on a phone, go ahead and zoom in. But I promise the next time I do this, I'll get better with clearing my screen. Okay. So again, it lets you take a minute to zoom in here if you're on a phone. And a lot of this is all CLI. We'll get to a nice little GUI when we go to the keyless mode. But what's going to happen here is just the nice out of the box. We'll just generate a public private key that's written right on disk and encrypted with, the private key gets encrypted with a passphrase similar to what you do with P12. So here we go. Very easy. Go to the place where, you know, store the key where you want, Cosign, generate key pair. That's it. There's your passphrase for protecting that private key. You know, make sure you verify it. We've all done this before. There's the keys. So let's look at these keys. All right. If you're in the space of routinely looking at base64, there's something that immediately pops out. Look how small that key is, right? These are all elliptic curve keys. Very small keys, which are very advantageous because that public key is what you pass around for verification. So gone are the days where we can just keep extending out the RSA to, you know, kingdom come. We have to start thinking about new protocols. So they just went ahead and just right out of the gate started using elliptic keys. And I think it's going to work to their benefit, our benefit, if we go ahead and utilize this tool. And let's look at the private key. Why not? Again, it's encrypted with that passphrase, but that's what it looks like, all elliptic curve. So what happens when we sign a container image? So let's do that right now. Okay. So what's happening here is a lot of things. So I'm going to pause it so I can explain a little bit. And if you look at just above where Cosign sign, I'm going to reference a key. This is that key we created. And I'm going to point it to my container registry. This is in Docker. And of course, I've already done my Docker login. You can see at the top there. So what's going to happen is Cosign goes out to that registry and signs the image. And then I'll show you the next piece, the way that this works. So there's our transparency log. So we can go ahead and query that with Recore and see what the deal is with that particular signature. That's that transparency piece. And then this triangulate command. This is very cool. So we're just going to run the triangulate command against the container, the one that we initially signed. And what you'll see here is, so little things about containers. Tags are certainly not immutable, right? Those can change each time you do a build. That's not something you'd ever want to trust. But the digest is more on the mutable side. And so what's happened here when they're signing it is they'll take your digest and create a tag, throw that .sig extension at the end, and push that as an image up to repository. So I'll show you what this looks like. So here is the repo, and there it is. So this .sig file is the one that I pushed. Now this isn't an image you can pull down and run, but you can query it. You can look with a tool like Crane or, oh geez, don't worry, I'll get it back. And you can find the way these signatures work. So they're just getting layered on top of them. So signing it once is certainly important, but if you start thinking about it, that signature can also help you to track the life cycle. So you can do a second signature, you can do the keyless mode, a lot of ways for however your workflow could be enhanced by this. So if we use a tool like Crane and look at the manifest of this particular image, well, I guess first we're going to verify. It's always important. So we want to verify this container image. And we're going to point it to the key we used to do the signing. So this is the public portion. There's the space. And pipe it to JQ so it's readable. It's telling me don't use that flag anymore. And it's going off into the infrawebs, and it will verify the image against that public key. And then we've get, oh geez, okay, well, a little editing magic. Let's look at the same thing using Crane, and instead of looking at that signed image, we're going to look at that image that got pushed up once it was signed. And so now we can see the certificate, we can see the chain, right? There's only it's not a long chain, it's a single certificate authority, but there it is. And the timestamp. So that will allow you to extend the life of this code past that 10-minute cert that will get issued in keyless mode. This is not keyless mode that we're looking at, but you still get a timestamp. So that's a pretty nice thing. It's all baked in to Cosign. And of course, the digest right up above, that gets moved into the tag. And yeah, so each time you sign, you get a new layer, and it gets stored in that .sig image. Okay, so I did it clear. Good job, me. All right, so let's turn on experimental keyless mode. So we're just going to plug in a variable, environment variable, turning it on. Now the way you can use this is do a cosign operation, but don't reference a key. And that just tells the package to use keyless mode. Well, of course, turning on the experimental mode helps as well. But so in theory, we should see a login screen, right? Because we're using OpenID Connect, and there it is. So these are our 3 providers like we talked about. Where I'm using Microsoft, my lab tenant here, it's got Azure AD. And of course, you can layer all sorts of controls on top of your identity with all these different providers. So you increase security that way. So once you're in and you've approved Sigstore as something that can use OAuth against your tenant, you get your certificate, right? Because you've authenticated to FullCo. And on top of that, it pumps in another transparency log entry. And then it pushes that package back up to your registry. So you could use that tool Crane again and check it out. So now we've got an identity. You can see it there at the bottom. So again, I'm sorry about the smallness of this, but that's my email address that I use to prove my identity. So now we're starting to see these pieces come together. There's a source of identity on the signature itself. You've got your timestamp, you've got the chain you signed it. And if I were to change this build, it would invalidate. So you would have that. This is not going to do everything in the security space, but it is a great tool. And I'm excited. So now let's look at these transparency logs. So we're going to use, that's very small at the bottom, my apologies, but we're going to use the Recore CLI to go ahead and query that transparency log. So all we have to do is point to that log index. So right there, we'll use 137.9265. And it will go ahead and scrape the transparency log and pull all sorts of pieces of information. So there's the log. There's the ID, the time that the signature happened, and we even see the certificate down there in the content field. So let's look at the certificate. We've got to pump that into base 64. So let's do that. So we'll write a little file with that info. And convert it to base 64. And this will be a format we're more familiar with. There we go. Now we can look at it in a nice, pretty GUI sense. So I want to do a little bit more than this demo looking at the certificate, because I think that really does show us the moving parts in a nice way. So here's, come on. I thought I edited this out. All right, there's the cert. There it is. Yeah, it was hard. Okay, so we've got our elliptic curve right there. The issuer is Sigstore. That's a Fosu root. And I want to show you that cert in a little more detail. So here it is. Same one. So 213 to 213. Now look how long this thing's living. So it was valid. It was issued on 4:18 p.m. It expired at 4:28. Okay, and then if you look at Sandfield, there's my email address. So that gets carried over to the transparency log. And if we look at what this key can do, it's got our EKU of code signing. So yes, this is a code signing cert. So in theory, why stop at containers, right? We could sign all the things with this free service. And I think that's what's going to happen. I'm sure they got to tread a little lightly because it's big money in code signing certs, but you can kind of use your imagination and see where this could go. Really could just be the free code signing solution for a lot of us. All right, yep. We're almost to the end, so bear with me here. The last piece is the second signature. So when we're going to sign it again, I'm appending the signature with that second sign equals true. You can plug whatever you want in there. And that gets stamped on to the into the metadata and into the signature. So you could sign this -A, dev or prod or, I don't know, Finland, you can, whatever makes sense to you. And if I get out of here, okay. So now with the second sign, we're going to go ahead and verify and see if we can see that tag, so to speak, come through. It's doing its thing. It's still doing its thing. And there it is. So very, very bottom, second sign, true. So I've just said, yep, I signed it twice. So scalability, big, big plus for this tool. So that's the demo. And essentially that's really all I'm going to say. I got a lot to say, as you can probably tell, but it's a heady kind of thing. So I wanted to allow some questions on this stuff. So I'll stop sharing and be quiet. So if you're joining a little bit late, yeah, we're talking Project Sigstore. the parallel I made is, making this project Sigstore, the Let's Encrypt a code signing free, easy to use, and affixes an identity to code. And so we're looking at it in the container image space, but I believe that this will extend to all code in the very near future. So that's what I got.
Hey, Aaron, can you hear me?
Hey, Sean, sound like an angel.
Good presentation, buddy. So I'm curious, what's the future look like for usage in the enterprise?
So the way I could see this is a little bit of here, a little bit of this, a little bit of that. I don't see a lot of use for all the package in the enterprise, because I'll give you an example. Say you're in finance, just hypothetically, and you need pretty good controls, pretty good security. A lot of times when you do a code signing, you don't just want one person to just stamp the signature. There's an approval process, there's a vetting. A lot of times you'll even have an M of N, so you'll form a quorum. You might split a private key throughout different devices, so all the people come together and do the device. So I think the pieces that we'll be able to use in enterprise will be Cosign and Recore. I think FullCo is going to work for a lot of folks that are designing outside of enterprise, or it's got its use case, but FullCo is something you never interact with, so it's very hard to audit, very hard to understand. It just sort of works in the back and issues out certs. So that's where I kind of see this. I could see Cosign coming in very easily, and I could see using keys between the keyless mode, or and then using your own root CA. I'm not quite sure how that piece works, because that's really very powerful for the automation and the pipelines to get that keyless mode. Then you don't have to worry about key security. So I would say the honest answer to that is a la carte right now. If you can get OpenID Connect to work with your own issuing CAs, great, right? That would be keyless mode. And Cosign is probably pretty close to it. But this isn't even really ready for full release yet. This is super early. I think they're shooting for August for a full release. So it's not even ready for enterprise, but the foundations and principles are. So that's where I could kind of see it. I could see you signing every single thing you want with the naming conventions and the workflows that make sense to your organization, but with pieces of this whole project, if that makes sense.
Yeah, a little bit, yeah.
Hey, Aaron, it's Danielle. Can you hear me?
Hey, Danielle, how you doing?
Good. How are you?
Good.
What do you see this potentially being an issue for like malware or other potential issues where pieces of malware or code isn't usually signed, so it isn't usually an issue? But if people are signing malware with this code, do you see that potentially being an issue?
Yeah, that certainly could be an issue, right? Because we'll think of it, if we think it through, if you trust the FullCo root CA and somebody is signing that code, you might gain the trust. You can do the scans against the code to make sure it's not malware. But in theory, that's an interesting observation, right? Because you've got that sort of credential, but at least you can track the identity of whoever signed it. So if they are using the FullCo, they'll have an actual valid email that you could go down and say, hey man, why'd you nuke my whole income, my whole source of support for my family? I mean, it is at least affixing an identity to it, but they aren't trying to be the end all be all for security. I think the push to sign code at least allows you to track what you're getting. And then on top of that, if you think about when you're doing the upgrades and you're doing the patches, instead of just going and looking at the whole code block in entirety, you could trace back some of these signatures to different build cycles and reference, like I said, that software bill of material. So if we take the malware context aside and look at this for actual legit software, very powerful. But yeah, you could totally gain a bit of notoriety by signing your malware. And we've already seen that. I mean, SolarWinds, you know, that was a whole signed piece of code that came down and just gutted the entire government. So yeah, I mean, it's not the golden bullet, whatever the cliche is, but I think the idea of putting that chain of custody onto this with a digital signature will help legit code. And then, you know, if you're sucking down malware and your scanners don't find it, yeah, that sucks. But at the end of the day, it's trust and verify. I don't know. I guess that's something, you know, honestly, I was looking at this more from the legit point of view. And I know with your security hat on, you could see how this could be twisted. And yeah, I imagine that's going to be something we'll have to think about.
Really good presentation. Thank you.
Thank you. Yeah, one more slide. It's a thank you slide. Show you. Thank you. There's my email address. So Alaska USA, that's my email address. You know, shoot me a question if something bubbles up. I do love this stuff. I'm just a crypto nut. And I think when people put this kind of ingenuity into cryptography, only good things can happen. You know, there'll be some bumps in the road, but you know, Acme protocol came out of Let's Encrypt, so something will come out of this, and it's going to be cool. I think someone who works with crypto can only just think the whole idea of third-party certificate authorities is not the best, right? Why should we have to pay a whole bunch of money to just secure one website? So these tools that make it free and make it reachable and make it easy are just going to help. I think they'll ultimately do more good than bad. So that's that. Oh, and thank you. Thanks for coming. Oh, I stopped sharing?
Yeah, you did.
Well, gotta show you the last slide. There it is. Thank you.
I had a question about the benefits of maybe signing personal projects. I've noticed on GitHub recently that they have this option to tick in the settings to not only sign your commits, but also choose like a vigilant mode where it will say specifically if the commits are unverified. So I'm curious how Sigstore might play into that and for signing on personal projects.
Yeah, that's a good question. I don't know the answer to that. I can only hint at what's happening. So I believe that a lot of people, a lot of partners are plugging this into their admission controls. That might be where it is, but I don't know. My whole space, I don't even have a GitHub presence. You know, if you wanted to watch me code, it would be like just watching a child draw a picture. It's very clunky. So I don't have that answer. I do know that the whole project Sigstore, they're not putting a lot of time into webhooks or admission controls. They're letting the community sort of just incorporate it in their own space. So that could be something. And you know, signing code in GitHub would be a completely different workflow. The fundamentals would be the same. But I don't know how they're handling keys or what their whole root of trust is or what they're even stamping on their project. So that's a good question. I don't have the answer.
All right, awesome presentation. And if anyone else has questions, feel free to jump in. We have some exciting stuff coming up and continuing to have some of our members share some of their experiences with us and some of their presentations like Aaron has gracefully taken his time to do for the community. If you do have any ideas of something you want to show or experiment or project, let us know. We can get you on here to share with the group. Thank you, Aaron, for your time. Does anyone else have anything closing out that you want to say before we shut her down? Crickets. All right, Aaron, thank you again for coming out and showing for the group.
Yeah, thank you.
All right, everyone, third Thursdays. We'll see you then and in Slack. Stay tuned. We got a lot of good stuff coming up.
Thank you.
Thank you.
Okay, I'll go ahead and stop the recording.